Today I want to talk about surface area, specifically about prisms and pyramids. So a lot of new vocabulary when you talk about these shapes because they're three-dimensional or solids. They have a little bit more vocabulary, or different vocabulary than some of the area formulas that we've worked with in the past. If there was a prerequisite to this, I would definitely suggest being a strong student dealing with area before you start this. I think that will definitely help you. Let's start off. It says the surface area of a solid is the sum of the areas of all the faces or surfaces enclosed. Solid, basically, that means a 3D object. So we'll be looking at 3D objects. Sum basically means we're going to add together each of the areas of all the faces. I think of a face, I think of dice. When you think of dice, you think of this cube that has 6 different sides, numbered 1, 2, 3, 4, 5, 6. Well, each of those mathematically are called faces. There are 6 faces to 1 die, or 12 faces when you deal with 2 dice. These are the surfaces that enclose the solid. So the faces include both the base and the lateral faces. So these are kind of some interesting terms here, bases and lateral faces. So we look at this first object. This is called a hexagonal prism. A prism has 2 bases, one on top and one on the bottom usually, and it's stretched some distance between those. So base 1 and base 2 are each exactly the same shape. They're congruent. And what happens is they're each stretched a certain length called the height. So we call these two things the bases. Because the bases are hexagons, that's why we call it a hexagonal prism. Each of these rectangles that are made up of the side lengths of the corresponding sides of the hexagons and stretched a very specific height, those are called the lateral faces. The lateral faces. Handwriting's not so hot. And then it's different if you just have one base. See, there's just one base down here. And what happens is there's only one base, and then each of these lateral faces for a pyramid, instead of going up to another pentagon like this, they go up to one singular point. Okay, so it starts off as a pentagon, and each of these goes up to one singular point and creates a whole bunch of triangles, and those triangles are called, again, the lateral faces. Because this has a base of a pentagon, this is called a pentagonal pyramid. So each of these are named after basically the shape that makes up their base. The hexagonal prism and the pentagonal pyramid are named after whatever their bases are, and then pyramid or prism specifically. So in the prism above, the shape of the base is called a hexagon. That's why it's called a hexagonal prism. And the shape of each of the lateral faces is a rectangle. For every single prism, and no matter whether it has a hexagonal or a rectangular or a triangular or a octagonal or whatever type of base, it's always going to have rectangles for the lateral faces, always. The pyramid above has a base of a pentagon. That's why, again, it's called a pentagonal prism, a pyramid. And the shape of each of its lateral faces is a triangle. All pyramids are made up of triangles on the sides. So when we look at this one specifically, there's some specific vocabulary that makes things a little bit confusing. If you think of this as a mountain, then there's a couple ideas. We can talk about the height of a mountain, which is basically from the ground all the way to the top. And you might think of that as either like an altitude, like how high it is in the air, or like the elevation, something like that. That is actually called the height, or H, of the pyramid. Not to be mistaken with any other heights, like a basin or a height of the actual base, but it's actually the height of the pyramid. You have to say all those words, the height of the pyramid. So I'm going to fill in this little blank here, the height of the pyramid. And then if this was a mountain and you were going to ski or sled down it, if you were going to zip down the side right here, that is actually called a slant height, or in a lot of places it's called because these triangles on the sides are called the lateral faces, a lot of places will call this the lateral height. And that's why it's abbreviated with the letter L, usually kind of a cursive L. So the lateral face of a pyramid is the shape of a triangle. We just talked about that. The height of the triangular face is called we'll call this the slant height. Again, sometimes it's called the lateral height. The lateral height. And that's why it's abbreviated with the L, kind of cursive. The slant height should not be confused with the height of the pyramid. These two things are often confused. They're huge things that people switch back and forth. People have giant questions about them. How does this work? The height, remember, is just sort of like the elevation, the altitude. How tall is the mountain? And the slant height is basically where you're going to ski down the side of the mountain. So this is the ski down the mountain. Okay? And when we deal with finding the surface area, when we talk about this, there's basically formulas. In the past, we've talked about how area has a capital letter. We've talked about how circumference has this capital letter. We've talked about how perimeter has a capital letter. Capital letters in mathematics mean something special. Dealing with areas and surface areas, those capital letters mean that you need to calculate something. So capital letter means calculate something. So here's what we have. We have the surface area, which I'm going to abbreviate with an S, is basically 2 times the area of the base plus the perimeter times the height. So 2b plus ph, and the b is capitalized because it's the area of the base, and there's 2 bases, so that's why it's 2b, and the p is the perimeter of the base. And it's driven that way. I think it's also important to talk about what this h is. The h is the height of the base. So everything is related to the bases. This is the area of the base, this is the perimeter of the base, and this is the height of the base. Each of one of those is important. For a pyramid, we have a very similar formula. It's still S. It's just 1b because there's only one base, and then it's 1/2 p L. Okay? Again, this is the area of the base. The area of the base. The perimeter of the base is the P. The perimeter of the base. And the L, again, this is called the slant height or lateral height. This is the slant height. Okay? These two formulas are going to serve you quite a bit. If you have a note card, I think those would be really, really helpful to put on your note card in order to keep track of those two formulas. Let's get into actually some examples. Some people talk about rectangular prisms, and I think rectangular prisms are really complicated, so I'm going to skip to kind of what I would call example 2. So you look at this shape and you notice that it kind of looks like a big drum. And it has a hexagon here, it has a hexagon on the other side. So the name of this is it's going to be called a hexagonal prism. The way that I know it's a prism is because there's 2 bases and they're just stretched some exact length, the 12 feet. It's stretched. That's called the height of the prism. And you know it's a hexagonal prism because there's 2 hexagons. So how many sides? I think that's a bad question. How many faces are there? There are actually, well, there's 6 rectangles around, and there's 2 bases, so there's a total of 8 faces. What are the shape of the base? Well, they're obviously hexagons, and hopefully they're regular hexagons for us. I'm going to skip these next 2 questions because I think they really kind of confuse things. I'm going to jump straight to the formula. S equals 2b plus pH. So what I'm going to do is, I don't know the surface area, I'm going to solve for that. And what I'm going to do is for each one of these capital letters, I'm going to put brackets. We use parentheses quite a bit in mathematics. I'm going to use brackets just to kind of help write out the formula and try to keep things a little bit organized. So the area of the base, since this is a regular polygon, is going to be 1/2 S times A times N. The perimeter, again I'll put that in parentheses, is just going to be the side length times the number of sides. And the height, again this height is probably the most missed thing. It's actually the height of the prism. In this case it's the 12 feet. It's the distance between the 2 hexagons. Okay. Now I'm going to substitute numbers in here. 2 times 1/2. I think this is kind of funny because the 2 and the 1/2 are going to cancel. The side length here is 6. The apothem, it tells me right up here, is 4. And the number of sides for the hexagon is going to be 6. Everything in parentheses here relates to the area of this hexagon. Then I'm going to find the perimeter of the hexagon. That's just going to be the side length, which is 6, times the number of sides, which is also 6. And I'm going to multiply that by the height of not the hexagon, but the height between the hexagons, which is the 12 feet. Again, this number is the most commonly missed piece of this as we move on. When you multiply this number, the 2 and the 1/2 are going to cancel, so we have just 6 times 6 times 4, which should give us 144. We will add to that 6 times 6 is 36 times 12 should give me like 432, I hope, which gives me a grand total of 576. When I talk about surface area, area always has square for their units. So this is going to be 576 square feet. Let's look at some more shapes. This turns out to be a rectangular prism. This turns out to be a triangular prism. And this, because there's only one base and there's one point up here, this becomes a pyramid. Maybe it's called a square pyramid. I've heard them called that. I've also heard them just talked about being a rectangular pyramid. Either one of those names will kind of serve for us. If we recognize that it is a pyramid, we're going to use a specific formula. I'm going to skip over this guy just to start off with. Really, you just have to identify one of the bases, maybe the front, and say that this is going to be 37 times 37. Actually, I'll do this one really fast. Surface area equals 2b plus pH. That's 2 times 37 squared plus 4 times 37 times the height. The height here is 9. When I multiply all these numbers together, quickly I get 4070 as my thing, and since I don't have any units, I'll just say square units. 4070. Over here, my base is going to be the triangle. There's 2 of them, so I say S equals 2b plus pH. I'll substitute in here. That'll be 2 times the area of my base, which is 1/2 6 times 8, plus the perimeter. My perimeter is going to be 6 plus 8 plus 10. That's the perimeter of the triangle, times the height, not of the triangle, but the height between the triangles, which is 7. Again, that's one of the most commonly missed things, that height, whatever that is. 2 times 1/2 is just 1, so 6 times 8 gives me 48, plus, let's see, this is 1824 times 7. Oh, I don't know what that is. But if we add all these up, we do get 216. I already put that in my calculator. So 216 square units for this. We'll talk about this pyramid. Again, a slightly different equation. S equals B plus 1/2 PL. Again, my base here is going to be 10 squared because it is a square, plus 1/2. The perimeter is just going to be 4 times 10 because there's 4 sides for us. And then I have to look at my slant height. Remember, the slant height, this L, is actually the slanted height where you would ski down. You have to decide whether it's this 12 or whether it's the 13. The 13 is actually the side length of the triangle. If you picture each of the triangle sides or the triangle lateral faces, what we want is actually the height of those triangular faces, which is going to give us the 12. So be careful with that. When we multiply all these numbers together, we should get 340 square units. Be careful when you're doing this to watch that plus sign. Watch this plus sign. Make sure that you multiply these correctly, that you add first, maybe use parentheses, and then multiply. Be careful with those. We can talk about the reverse processes as work backwards. Okay, that's kind of a mathematical talk for, we're going to give you the surface area, we need you to find something else. And they kind of give you some hints on here. They kind of shade in some of this area over here to kind of give you a hint, hey, by the way, we want this thing and this thing right here to be your bases. So in this case, we have a rectangular prism. We want this right side here to be your base. So we have surface area equals 2b plus pH. So that means 142 is going to equal 2. Base is going to be 6 times 9. My perimeter in here is going to be 6 plus 9 plus 6 plus 9. And my height is my distance between my two rectangles. That's just going to be x. I'll multiply this out. That's 2 times 54, so that's going to be 108 plus, see that's 15 and 15, that's 30x. I'll subtract 108 from both sides. I'll have 34 equals 30x. Divide both sides by 30. And our height, it's not much. It's approximately 1.13 feet. 1.13 feet when you put that in your calculator. Over here we have another prism. So it's a triangular prism. It's 2b plus ph. Surface area here is 220. We do twice the base. The base is going to be 1/2 of 8 times 10. The perimeter is going to be 8 plus 10 plus, the hypotenuse, we'll have to figure out what that is, times the height, which for us is x. So the idea is when I'm trying to plug all these things in, I do not know this side length right here. It's not given to me, so I may have to do a little bit of work. Because this is a right triangle though, and I know this leg and this leg of the right triangle, I can actually use the Pythagorean theorem, oh my, in order to calculate the length of that hypotenuse. So if you remember, it's hypotenuse equals leg squared plus leg squared. So that'd be 8 squared plus 10 squared. That'd be 64 plus 100, so that's 164 equals the hypotenuse squared, or the hypotenuse itself is going to equal somewhere around 12.8 centimeters. So I'll just plug in 12.8 right here. So I have to do that earlier work just in order to get this answer down here so I can continue working with this. This would give me 220 equals 80 plus 30.8x. I'll subtract 80 from both sides. I'll have 140 equals 30.8x. When I divide both sides by 30.8, I'll get my final answer here of x equals approximately 4.55 centimeters. It's going to be the distance between my two triangles. We're working with surface area and volume. This unit right now is just dealing specifically with prisms and pyramids.